Hello, and welcome to another exciting episode of Breakfast with Unity, your breakfast of champions. So today we're going to be doing some Vertex shader stuff, and we're going to be doing a little bit of copy pasta and a little bit of original work on this one. Mainly, I want to just get you guys the idea that you can deform vertices using your Vertex shader, and you don't have to do it in CPU and rebuild the meshes and all this other stuff. You can actually just modify them in place using a Vertex shader. And so, first of all, what we're going to do is I'm going to go to Unity and we're going to open up our project. And I've already added a file in here, perlin 2002 CGV001292. We'll be going over this in a little bit. We're not going to be using it just yet. First, we're just going to create a very, very basic example. So I'm going to create a sphere, and might as well just save the scene in the where we need it here. Vertex shaders, we're going to call this Vertex shaders. All right, I'm going to position the camera a little bit lower and move it in closer, and we're going to create a light in the scene as per the usual. So what we're going to do first is we're going to make a very basic shader. We're going to create a new shader. What are we doing? We're going to call this, I'm going to call it basic vertex extrude example. And the reason we're going to call it that is because we're going to be pulling it from Unity's own little manual here. So if you search the internet for surface shader examples, you'll get this page. Here's the actual web address if you want to get to it. But basically, there's a bunch of different examples for surface shaders. And surface shaders are what we were using in the last one, where you define color as like the albedo, and there's different like layers that you basically just apply to in the surface. You typically the surface replaces the fragment shader, or what is known sometimes as a pixel shader. And it's because it's actually doing kind of a multi-pass type. Well, it's not multi-pass, but it's one pass. But it's breaking up the different portions of it that normally are considered part of the pipeline into separate things, so that they're easier to work with. But you can still use them with a vertex shader. And so if you scroll down here, there's at some point an example, and it's kind of hilarious looking. There he is, this fat soldier here. It's this normal extrusion here. And so we're just going to copy this whole thing over and put it into our shader. Don't save. All right, so I'm just going to take this and I'm going to replace it with our whole thing there. So it'll show up in example normal extrusion here. And so if we apply this to our sphere, it will be very boring, actually. But we're going to do it anyway because it's important to see this. So what are we doing? We're going to create a material based on our shader. So now we have our basic vertex extrude example shader. And it's already set to example normal extrusion. That's because I had this selected before I created it. You can always just pull it down and find it in the menu. But it saves you a little bit of time to just have it selected first. And we're going to put this on our sphere. And you'll see that the sphere got bigger. And we have this slider now that can make the sphere bigger or smaller, which seems really pointless considering it's just scaling. Now, if we had a slightly more complex model, as a matter of fact, here's what this will do on a cube. I have a feeling it's going to explode the cube. Let's find out. I haven't actually tried this, but I'm curious. If we put this on our cube, because I think the faces are detached on the cube. Yeah. The faces are detached on the cube. So you'll see that this is a little bit more interesting result because it's not just scaling it. It just pulled the verts and pushed them out in their normals. That's because these faces aren't actually connected in any way in this cube model. We could also do a much more fantastic example. Like we could create our, we could grab one of our characters here. Prefabs. Wait, no. Characters. Third-person character prefab. I'm just going to grab him and throw him in here. And we can make him look really horrific using this. I'm just going to replace he has a few different shaders to replace, so I'm just going to do like one or two. We go to his body, and all of this stuff is here, so I'm just going to go example, normal extrusion, example, normal extrusion, example, normal extrusion. There we go. And now we have, let me turn him around so that we can see him a little bit easier. So now we have a character that looks really screwed up. So we can then go to our little example here, and we can pull this slider, and it will all of a sudden make a little bit more. Whoops. Wait, why didn't that affect him? Oh, that's because I didn't replace the shaders. I just changed it on his things here. So let me just find his shaders real quick. There we go. We'll just grab all of these, or all the ones that we changed. I guess we, hold on. Specular. Oh, okay. So plastic skin suit. Those are the only ones we did. So now we can change the extrusion amount, and you can see that he becomes this. He's this normal looking character, and then he becomes this horrible plump looking dude that looks like those little figures that you paint or something from Japan, so, or from wherever they're made. So so cool. So this is neat stuff. We're not going to save these changes to this guy's prefab or his things, but you can play around with different models and stuff and do things with that. So now we've just created that little copy paste super simple example. We're going to do something a little bit more fancy. So here's where this file comes from. So I found this one on a forum. Apple Motion here created this nice little script that you can download. He was kind enough to share it with the world. And what it is his port of this JavaScript implementation of a perlin noise generator. The reason we need this is because in Shaderland we don't have access to mathf dot anything. We can't just grab stuff from that stuff. It's all set up for CPU generation. This is a fast method that evidently works in CG because his conversion worked out pretty nicely. And this is actually the code to generate. This actually contains the code to generate perlin noise. Now his is a little bit more fancy than what we need. He has a perturbation, or what is it called? He has a permutation system based on a map, which we're not going to be using. But we are going to be basically clipping all this stuff for generating the noise from this script. We're not going to be doing his fancy. What his shader actually does is, if we just create this real quick, let's just show what this does first, so that people can see where the magic's coming from. Create material. It's actually not that interesting looking, and I might just not know how to use it right. Let's get rid of this cube. Let's get the sphere, and we're going to apply this shader to it. So this one, you'll notice the sphere got smaller because this doesn't have a vertex shader. This one is using the perlin noise to generate the texture format, and it actually doesn't seem like it works on the horizontal, but I'm not sure exactly how to set this thing up. You can change some of the values. You can see that like the scale Y works, but scale X doesn't. So I'm not sure exactly how the use case is supposed to be done here, and maybe it's because I don't understand the permutation table aspect. So what we're going to do instead is we're going to, I'm not going to use this shader. We're going to create a new shader. We're going to duplicate our basic vertex extrude example. Yeah, save those things. I don't care. And what we're going to do is we're going to call this perlin vertex extrude. So let's go in here, and the first thing we should always do is change the name. So what we're going to do is we're going to call this one perlin normal extrusion. We're just going to put it at the root. So this one will just show up in the list. And what we're going to do is we're going to grab the perlin noise portion from here, which is this noise function and these other functions that are used by the noise function. So we're just going to grab all of this. And you can see that this goes in the CG program section, so we're going to go ahead and put this in the CG program section here. I'm going to try and tab this out so that it looks a little bit like it's in the right place. Oh, well, that's wonderful. Oops. I love it when things are not using tabs. Oh, well, whatever. At least it's closer. So, if we save this right now, I think we're going to run into an error. And I actually don't know why we run into this error. Although we didn't run into it. Okay. Alright, well, before it had a problem with this line, and we're going to have to change this line anyway, but that just kind of worries me that things are working a little bit differently than they did last time. Like, this doesn't even exist. I don't know why it wouldn't give me at least one error right now. I'm going to create a new material based on the shader, and we're going to put this on our sphere to see what's going on. Alright, so it's still doing the same thing that it was doing before. Make sure that everything's set up right. Perlin, normal, extrusion, good. Alright. So, I am kind of worried that this isn't actually compiling. I'm going to just add a space and hit save and go back in. Alright, I'm going to quit Unity. Hopefully we're still broadcasting. Let's actually check that. Let's just find out if we've ruined anything. Yay, okay, it looks like it's kind of working. I don't see anyone complaining, at least. So, I guess we have to use the function for it to mess up. Alright, so let's go ahead and do that then. What we're going to do is, I'm going to make a change here. We're not going to use the permutation map. We're just going to multiply t by 255 to give it in the proper range that we want here. And the rest of this we can use as is. So what this script did, I didn't actually go over it, is it specifies a surface shader and a vertex shader. And so surf is the surface shader here, which just sets the color, the albedo. Albedo is another term for diffuse. I don't know which one's older or which one's more correct. But yeah, it's another term for the diffuse component. So this is just the diffuse color that they're getting here, and this is just grabbing it from the texture map, which is fine. We don't want to change that. This is the vertex though. So all this is doing right now is taking the vertex and it's adding its normal, vertex normal, so it's moving out in its normal. So its normal is the direction perpendicular to where it's at on the surface of the model. And times the amount, which is just that slider, which just can go from range -1 to 1. So what we're going to do now is we're going to add an additional component here. We're going to additionally multiply noise based on this position. So we're going to do v.vertex.x, v.vertex.y, and v.vertex.z. And save. Okay, perlin normal extrusion instruction limit 256 exceeded. Alright, good. At least we're getting some errors. That's great. So, we have too many instructions to compile this program, and what that means is the 256 limit is based on, I think, shader model 2 is the maximum you can have. So we're going to have to change our shader model just because of the number of operations that are being done by this. There may be more efficient. P.S. There may be more efficient ways of doing the perlin noise on GPU. I am not sure. This is just a few hours of research here. So keep in mind there's always different ways to approach problems. So what we're going to do though is we're just going to add pragma, and I'm going to copy it from here. Target 3.0. This is it. Pragma target 3.0. So we're going to save this. And now you'll see that the sphere has deformed. we now have this kind of potato sphere thing. And so this works. It currently just has the amount, so you basically can just stretch it out in either direction, which isn't really what we want, but it's a start. So I'm just going to move this all the way out to one side, and what we're going to do is we're going to add a couple more variables. So I like to copy and paste, so I'm just going to grab from here. We're going to need a couple vectors. I'm just going to grab this. So we're going to have one called, I'm going to call this perlin, what did he call his thingy? Scale. There we go. That's the word I was looking for. Perlin scale. That makes sense. And we're going to default the scale to 1, 1, and 1. And we're also going to grab this is just how it's defined for the properties that show up here. So we're going to do perlin offset. And I'm going to go ahead and put it in here. And no, let's do that for right now. So we're going to default those to 0 on the offset. So I'm just going to call this perlin scale and perlin offset. It doesn't actually matter what you put in here. This is just human readable stuff. And what we're going to do is we're going to add these two variables down here. I'm going to put them after our definitions for our perlin noise. We're going to do a float 3 perlin scale and float 3 perlin offset. So now what we can do is we can add these into our equation. So what we're going to do is we're going to do vertex.x times perlin scale plus perlin offset. Now these are vectors, so we need to actually give them the components. So .x and .x, and we just grab this and paste it 2 more times and change the x to a y and a y and change it to a z and a z. So now, save. It'll look exactly the same, but we have some more variables. So now we can actually change the scale of the perlin noise, and we can actually start getting some cool effects. So if we just change the offset, you'll get this cool kind of hypnotic sphere thing going on. It's awesome. And it's just using perlin noise, and it looks really sweet. We can also make it so that it's spikier by increasing the frequency. And we can just push the perlin offset and make this really cool looking just object shader thing. It's awesome. So so there we have it. We're going to add one more thing though. We could now animate this just by changing the perlin offset in CPU. But we can also animate it using the time variable that we have available to us inside of the shaders. You can just do _time and get the current time. It's a special variable that Unity sets up for us. So what we are going to additionally do is I'm going to create one more thing here. We're going to call it perlin. This is the reason I typed it before. Perlin speed. And again, I'm going to default these to 0 in this case. And we're going to call this perlin speed. So now all we're going to do is we're going to additionally add time times perlin perlin speed dot x, and we just add this to all 3. Boop and boop. So we just need to make sure this is z and perlin speed dot y. Save. I'm going to actually break this up into a few. I could put a couple of breaks in there so that we can read this a little bit easier. So there we go. This will still compile. You can have as many spaces and stuff as you want. The semicolon is actually what denotes the end of the line. That's the reason that the semicolon exists in code. So save, and I messed something up. What did we mess up? Shader, undefined variable, perlin speed. Oh yeah, we defined the inspector thing, but we did not define the variable here. So float 3 perlin speed. Save. There we go. So now on our sphere, if we hit play, nothing will happen. It'll just sit there. But if we change the perlin speed to something and hit play, it'll start moving. And this is all being done on on the GPU. You don't have to, there are no additional scripts or anything driving this. And we can just adjust this value to something high. And you can see that it kind of does additional stuff when you're actually changing the value, but once it's stabilized, it just animates. So 40 looks pretty good. I'm just going to have that be the example. You can, of course, change which direction the stuff goes. It's hard to tell in Sphere what's actually going on, so it doesn't really matter. You just can change one and it'll be effective. So let's go ahead and save scene, save all, save project, and I would say that's a successful episode. So, thank you very much for joining me this morning. You can tweet me at, you can email me, pushypixels@pushypixels.com. Please email me if you have questions or if you just want to talk. You can also tweet me at Drakfire, that's DRAKFYRE. Please support us on Patreon, patreon.com/cookingwithunity. We really need your support, and thank you very much. You guys have a great one, and I will catch you soon with more Breakfast with Unity and Cooking with Unity action to be announced. See ya!